So today we're going to look at a logarithmic function, y equals log base 2 of x plus 3. And we've done a little bit of evaluating of logarithms in class, but the purpose of this video is to get you guys to understand how to find the domain of a log equation based on the equation, okay, or the graph, but it's pretty easy to find domain based on the equation. You just have to remember kind of what to do. And then also a little bit of more practice with evaluating and solving. These are both things that you will understand when I do them. And then also graphing, this kind of icing on the cake, but graphing. All right. We're going to get a little more in depth with evaluating and solving though in this video. Okay, so there will be some new components. So first of all, with domain. I mean, I could tell you that all we're doing to find domain of a log equation is we just set whatever the argument is, whatever the expression that's next to the subscript, next to the base, whatever this expression is, we just set that to be greater than 0, not greater than or equal to, and then we solve this equation just by getting x by itself. In this case, it's just by taking away 3. So the domain is just x is greater than negative 3. If we want to be fancy, we can write it like this. Right? This is set notation. We could also write, negative 3 comma positive infinity, either way. But this is a little more common because you're always setting up and solving an inequality. So this is the answer, all right? Now, why do we do that? Let me make a more basic example, all right? So as you guys know, y equals log base 2 of x, just that general equation. If we're talking about that domain, well, this graph looks like this, if you recall. It's pretty much like this. That's that log graph, right? The domain here is that x is greater than 0, right? Not or equal to, it's just greater than. And the reason why that happens is because what this means is that 2 to the y equals x, right? This means if we're writing this log equation in exponential form, this would mean that 2 to the y equals x, right? This to this equals this. Now, if you think about what this means, you're raising the number 2, the positive number 2, to some power, which is y, and you're equaling x. So you're raising 2 to some power to get x. Well, what would be the restrictions on x then? If y is a negative number, x would become a fraction, right? Like 1/4, 1/8, 1/32. If y is 0, x would be 1. If y is a positive number, then x would be like 4, 8, 16, etc., and so on and so forth. What x will never be is 0. X will never be 0. You can't raise positive 2 to any power to get 0 or to get a negative. So that's why generally, guys, that the domain, the restrictions on x is that x must be a positive number. X is greater than 0. That's the domain of the parent logarithmic function, all right? But when the argument is not just x, what we're doing is we're saying, all right, well, in the general case, it's the argument, really, the x, the argument, that has to be positive. So if the argument is not just x, all we have to do is set that to be greater than 0 and then solve it. Like if the equation was y equals, or f of x equals log base 5 of 4x minus 1, we would do the same thing. We would say, all right, 4x minus 1 for the domain, 4x minus 1 has to be greater than 0. Add 1 divided by 4. X is greater than 1/4. That's our domain. It's just like that. And yeah, you can put that in interval notation if you want, but this is fine. Okay? That's how you find domain of a log equation. You just set the argument to be greater than 0, and I kind of explained why we do that. All right? And then you solve that equation. I need an eraser. Sorry. Almost back. Okay, now, that's domain. So we have that under our belt. Now we want to evaluate. So the domain, I'll write this again. Let's use the fancy notation. X is greater than negative 3. Okay, now evaluate. Let's evaluate, let's say, we'll do a couple problems. F of 1, F of 5, and do I have room out here? Yeah. What about f of 29? And then one more, f of 2. Okay. So f of 1, we just plug in 1 for x, right? So we end up with log base 2 of 1 plus 3 of 4. And all we've got to do is evaluate this. What is log base 2 of 4? Remember, that's asking you what power of 2 gives us 4, right? The subscript is the base. This means 2 to what power is 4? And the answer obviously is 2, okay? This one, we plug in 5. Log base 2 of 5 plus 3 is 8. Log base 2 of 8, that means what power of 2 gives us 8? The answer is 3. Right? Evaluating is pretty easy. Once you know what a logarithm is, what it means, you can do these pretty quickly. F of 29, 29 plus 3 is 32. Log base 2 of 32, as you know, that's just 5. So that's all well and good, right? But what about f of 2? What about f of 0? What about f of, negative 3, and so on and so forth? Those are a little more challenging. Let's talk about some of those. In fact, instead of doing f of 2 now, let's talk about quickly, let's throw in negative 1. All right? F of negative 1, plug in negative 1, you get negative 1 plus 3 is 2, right? So you get log base 2 of 2. 2 to what power is 2? It's just 1. Keep going. Let's try f of negative 2. All right? Log base 2 of negative 2 plus 3 is 1. Log base 2 of 1 means 2 to what power is 1? It's 0. Right? You got to know your rules of exponents. And now I'll slow it down a minute. All right? So we have all these sort of what I'd call easy ones, right? Now, notice how the domain is x is greater than negative 3. So if I put a number in for x that does not fall in this set of numbers, like negative 3 itself, or negative 4, or negative 5, what will our answer be? Well, there is no number, right? If I try to evaluate a function with a number that's not in the domain, then there is no number. There is no output for y. So we would just write the circle with a line through it, which means there is no number, okay? Like, if we did want to do f of negative 3, for instance, or f of negative 4, or f of negative 5, we'd now end up with log base 2 of 0. Log base 2 of 0. 2 to what power is 0? You can't have that. You can't raise 2 to any power to get 0. So there we would just write, boom. There is no number. So you can just write this symbol. All right? It usually means no solution. All right? Now, that's all well and good, right? But what kinds of problems we haven't done is, what if your argument is not a power of 2? What if your argument is not a power of 2? What if it's log base 2 of 5, or log base 2 of 17, or something like that? We'll do that in class, okay? So let's hold off on that. You'll need a calculator for that stuff. I just wanted to do a little bit of review with this. I see it's getting to be a long video. Now, solving some equations. So we've got evaluating done. Let's do some solving. Let me erase the bottom line here. Okay. Solving. What if I said, I'll erase this one. What if I said, solve for x, given f of x equals, 3. Well, in this case, in the evaluating problems, right, we plugged in these numbers. You're evaluating f of 1. It means plug in 1 for x, right? In these problems, you're solving for x. So you're going to have an x in your equation. What you're given is you're given f of x is 3. This is 3. So your equation here would be 3 equals log base 2 of x plus 3. Now, to solve this, usually I ask you to state the domain first. So you would just have to, again, like this, like we did up here, you would just set x plus 3 is greater than 0 and solve that. But now, we're solving this for x, okay? The way you solve a logarithmic equation is it becomes a very similar problem like your exponents quiz, okay? All you've got to do, you've got to know how to write this in exponential form, okay? So if 3 equals log base 2 of x plus 3, your first step should be to write this without logarithms. This would mean that 2 to the third, you got to make sure you get the order right, the base, and that's the exponent, 2 to the third equals x plus 3. Right? This is the purpose of that first side of the packet, to get you to work with putting the log equations in exponential form and vice versa. So you understand that this, or not that you understand, so that you're able to solve a log equation. because the first step in solving log equations is to write the equation exponentially. 2 to the third is x plus 3. We get 8 equals x plus 3. Take away 3, x equals 5 is the answer. And just double check to make sure that 5 is in the domain, right? It is. X is greater than negative 3. 5 is in that domain, right? One more solving problem, and then we'll call it a day. Let's say we had solve for x given f of x is negative 4. Okay, so we'll have to deal with some fractions here. So now you have f of x is negative 4. So negative 4 equals log base 2 of x plus 3. And guys, oftentimes I'll just give you a problem that doesn't even introduce this as a function. It'll just give you this equation and say solve it. So that's what you'll have to do here. Again, the first step is to write this equation in exponential form. 2 to the negative 4th power equals, again, x plus 3. The equation that results might be some kind of a weird equation. You might have a fraction equals a fraction, where you could cross multiply. A lot of different possibilities. 2 to the negative 4th is 1/16. 1/16 equals x plus 3. When you have a fraction in an equation, you might recall this from Algebra 1. When you have a fraction in an equation, you want to multiply it. Not that you have to do this, but it's going to be easiest to solve from here if you multiply everything by that denominator so you clear the equation of all fractions. All right? 16 times 1 over 16, as you know, is just going to be the numerator, 1, equals 16x plus not 3, but plus 48. Okay? So I just wrote the log equation in exponential form, changed the 2 to the negative 4th to the fraction, multiplied by the denominator, distributed to everything, and now just get x by itself. Take away 48, you get negative 47, and you'll divide by 16. So the answer, x equals negative 47 over 16. It's ugly, but, you know, it's the answer. All right? And this also is in the domain. Okay? X is greater than negative 3. Negative 47 over 16 is like negative 2.9 something. So yes, it is barely greater than negative 3. All right, so hopefully you understand now how to find the domain. That's how it started. Evaluating you kind of already knew. And then solving this stuff. I didn't get into graphing. That's fine. All right?